Okay, so you saw before how we did the fundamental theorem of arithmetic. Let us know that all of our whole numbers bigger than 1, if they're not prime, then they have a set of prime factors, and there's only one that goes to that set. And then we constructed those up through 20. Now I'm going to show you how to break any whole number greater than 1 down into its prime factors. That's prime, called prime factorization. So we're just going back the other way. Prime factorization. Okay, so let's start with a really small number. Let's start with 4. This is how you do it. Okay, so what I say is, what is my smallest prime number? Well, the smallest prime number is 2. You always start with 2. And then the question is, will 2 go into 4 evenly? If the answer is yes, and all even numbers, yes, 2 goes into all even numbers evenly, you're going to pull it off to the left and then circle it. You'll know why later. Okay, so then the question is 2 times what is equal to 4? Well, 2 times 2 is equal to 4. Now I have to ask myself, is 2 prime? If 2 is prime, then I'm done. If it's not, then I would keep breaking it down. So there's the unique set of prime factors for 4. 5 is prime, so let's go ahead and look at 6. Let's do prime factorization of 6. Question, is 6 prime? If it is, you're done. You cannot factor it if it's prime. But it's composite, so it can be factored. So again, I ask myself, what is the smallest prime number? It's 2. Will 2 go into 6 evenly? 6 is an even number, so yes, it will. Pull it off to the left and circle it. 2 times what equals 6? Or 6 divided by 2 is what? Same question. 3. Starting all over right here. Is 3 prime? If it is, yes, I'm done. There's my unique set of prime factors for 6. Okay, 7 is prime, so let's look at 8. Is 8 prime? No, it's composite. Will 2 go into it? Yes, it will. So you pull your 2 out off to the side here, circle it to the left, okay? 2 times what is 8? Well, 2 times 4 is 8. Now I ask again, is 4 prime? No, it's composite. Will 2 go into 4? Yes, pull it off to the side. Pull it off over here to the left and circle it. 2 times what is 4? Well, it's 2. Okay, so now I'm with 2 and I say, is 2 prime? If it is, yes, circle it and you're done. That's the only one that doesn't get pulled off to the left. So there's the unique set of prime factors for 8. 2 times 2 times 2. Okay, 9. Is 9 prime? No, it's composite. Will 2 go into 9? No, it won't. It's an odd number. So you ask yourself, what's the next biggest number, or the next biggest prime up from 2? Well, it's 3. So we check 2, then 3. Will 3 go into 9? Yes, it will. Pull it off to the left and circle it. 3 times what is 9? Well, it's 3. Is 3 prime? Yes, it is. You're done. There's the unique set of prime factors for 9. Let's try 10. And as you can see, we're going through the same thing. It's just going backwards from what we did before. So will 2 go into 10? Yes, it will. Oops, how many times? 5 times. And 5 is prime. So there's a unique set of prime factors for 5. 11 is prime. Let's look at 12. Will 2 go into 12? Yes, it will. How many times? 6. Is 6 prime? No, it's composite. Will 2 go into 6? Yes, it will. How many times? It'll go in there 3 times. Is 3 prime? There you go. The unique set of prime factors, which you should have seen from your fundamental theorem of arithmetic video. 2 times 2 times 3 gives me 12. So this is how these work. And the question then becomes, they're fairly simple when they're small like this. But what about when you have what about a great big number like 486? Well, first thing I do is I look and I say, is it composite or is it prime? Well, I know it's composite because it's an even number. How do I know? Because the last digit here, 6, that's an even number, 0, 2, 4, 6, 8. Then this whole thing is an even number. So then I do know 2 goes in there. So that's the first one I check. Put it in my calculator and I find out that 2 goes in there 243 times. Well, now I know this one's not even because 3 is not an even number. So then I have to check, will 3 go into it? Well, here's the trick to that. Add all 3 digits up and see if that's divisible by 3. So 2 plus 4 is 6, plus 3 is 9. 9 is divisible by 3, so 243 is divisible by 3. So I know that goes in. Put that in my calculator, and it says it is 81. Okay? Now, is 81 prime? No. And I don't check my 2's anymore. I'm still checking 3's. If there are 3's, I'll check 5's, 7's, and on up in my prime numbers. So will 3 go into 81? Well, 8 plus 1 is 9. 9 is divisible by 3, so 3 will go into 81. And then I put that in my calculator, and it comes out to be 27. Check it too. Is it divisible by 3? Well, 2 plus 7 is 9, so that is also divisible by 3. And 9 is divisible by 3, so it comes out to be 3. And I know that 3 times 3 is 9. Well, check it again. Is 3 prime? Yes. If it is, then you're done. That's the only one that does not go out to the left. So you want all your primes out to the left. So the unique set of prime factors for 486 is 2 times 3 times 3 times 3 times 3 times 3. Okay, and you'll see why we do that in the next session. So if you have any questions, just let me know. Thank you very much.